So that's the title. We're going to prove lines parallel. We're not going to do a formal proof yet. That is going to come in chapter 5, but we are going to do just kind of single step kind of proof type things. And so we're going to go over what we need to know on this. Okay? So there's the title. I'm going to make it go away. And I had to have a thumbnail so it is organized for people missing it. And fortunately, this class, most of you are back, but not everybody. All right. So we're going to have several theorems here. And I'm going to basically not make you write all of them, but I want you to understand what these theorems are. So these are the ones that we're going to focus on right here. So we are going to focus on, this one is called the alternative. That is lies. This one's called the corresponding. And this is all on page 127. Corresponding angles converse. Okay, do we remember what the converse means? It means to do what? Switch the order. Flip it. Flip the order. So we're dealing with the converse today. This is the alternate. Interior angle converse. This is the alternate. I don't know why I'm writing the whole thing out. Exterior angle converse. And this is the consecutive interior angle converse. So basically what all of these converse says, if like in this case, it would be if I'm going to use the code, then lines parallel. Okay, so if, and so I'm going to give you an example of this so you can see it here, what this means. So it's just backwards of what we learn, and so I don't want to write too much because I don't want you to get confused that they're two separate problems. They're the same problem, they're just backwards. Okay, so basically what we got going on here with the corresponding one, angle 1 and angle 2. So if angle 1 is congruent to angle 2, then P is parallel to Q. Okay? It's kind of opposite what was before. Before, we started out with parallel lines, and that meant the angles were. Okay? So I don't want to overly confuse you or overly take notes on this, because I think that we can do this stuff. There's one theorem that is separate that we are going to write down, and I'll try not to go too fast. This one is not a converse. So this is the transitive property of parallel lines, and it is a theorem and a property. So we know what the transitive property is, and so I'll just show you how it works with parallel lines. Okay, kind of like a ladder. I'm going to call this P, Q, and R. So basically it's just if P is parallel to Q, and Q is parallel to R, then P is parallel to R. Okay? Makes sense, right? If these two are parallel and these two are parallel, they're all parallel. So in fact, you know, if you had a whole ladder, all of these, well, you can't see it. All of these are parallel on a ladder, right? Or on my piece of paper. They're all parallel. They'll never intersect. And so you can just kind of move up and down the ladder is basically what this means. Okay, and we'll see a little bit of examples about that. So we're actually going to just look at examples on what you're going to do. This is kind of a short lesson, although it might take you a while to do the work. So I'm going to start with number 3 on page 130. I don't know why I did it there. 130. And we're going to start with number 3. All right. People try to make this one into something difficult. It is kind of a tricky way to ask a question and do this exact same thing you did on the last assignment. Let me not draw it backwards. Okay, the directions say find the value of x that makes m parallel to n. Find the value of x that makes m parallel to n. Well, for those to be parallel, that means that 3x would have to equal 120, right? So basically, it just wants you to solve this and show your work. Okay? And it kind of wants you to, and so I want you to, why did I, no. It kind of wants you to say, well, that is corresponding angle converse. That's what proves that m is equal to n. So basically, if x is 40, m is parallel to n. So just put that, you use the, is that corresponding angles? Am I right? Okay. All right, so that one's not hard. Let's look at 13. This 13 is more what I'm talking about, what is more important on this particular lesson. Where you kind of get the, yeah, that's an ugly line. Let's pretend that I didn't do that line. I'll try to draw exactly what's in the book. All right. And then it marked this. Are these lines parallel? Well, how can I tell? Well, basically I'm looking right here. That's angle 1, that's angle 2. Those red lines mean that they're congruent. So angle 1 is congruent to angle 2. I'm missing. That means that m is parallel to n based on the alternate interior angle theorem. No, that's not right. It's not based on the alternate interior angle theorem. It's based on the what? Alternate interior angle converse. Okay? Does that make sense? Because we're, instead of starting with parallel lines, now we're starting with the angles, and it proves them parallel. Okay, that's basically what we're doing. Some of these you won't be able to do. Some of these will not have enough information, and so that's what I want you to be able to do so we can have a discussion about it. Moving on to 21. 21. Let's get a good model of 21 so we can look at it and see what we've got to do here. Okay, so I'm going to start This is kind of a puzzle. This is kind of a puzzle. So, what is the word that defines these two angles? Do we have one? And I forgot I have to do this. A, B, C, D, E, F. I don't have a vocabulary word for those, do I? So what I need to do is I need to move this. I need to say that 57, I think, for some reason, I think that this angle right here equals 123. What word would that be? How would I know that 57 and 123 would be there? What word is that? I hear it, but it's not very loud. What did you say? It's not consecutive, because keep in mind, I'm dealing with an X. I'm not crossing the boundaries yet. When there's two things right next to each other and they equal 180, what's that going to be? So angle ABE equals 123 because of the linear pair postulate. Does that make sense? So nod your head. Does that make sense? That I can do that? 57 plus 123 is 180, right? Okay, now I can do this. I can do, since 123 and 123, since angle ABE is congruent to angle DE, they don't give me another letter, do they? Well, that's not okay. How am I supposed to write that down? Here, I'm going to give you a cheat. Let's not do this ABE. Just label this angle, angle 1. Label this angle, angle 2. So we can, because they're not giving me enough letters. So angle 1 equals 123, linear pair postulate. Angle 2 is congruent to angle 1 because of the corresponding angle converse. Okay? And that's how you prove these lines parallel. Questions? What we're kind of doing is a little bit of a proof, but not finishing it, but where we just identify our movements by theorems. Because we're kind of working our way up to doing a formal proof with geometry, but we're not going to go there all the way right now. Okay? So what I want you to do is do this. And so I'm going to give you the assignment. The assignment is 4 through 8 evens. Because they're basically what we did yesterday, I'm not going to make them hard. We're going to do 13 through 18 odds. I guess we already did 13, huh? You did 13 in your notes, so we only need to do 14 through, and not odds, all. 14 through 18 all. And then we need to do, I did this again last hour. We need to do 14 through 25 all. And of course you don't have to do 21 again unless if you don't want to. So I did that last hour, was going to break it up, but I don't need to. And this is on page, here, this is ugly. Let's make it less ugly. Very, very ugly. All right. This is, of course, on page 130, 131, 4 through 8 evens. 14 through 25. Oh, that is better. And I'm closing this off.